this video, we'll understand about binomial coefficients. Let us consider the following algebraic identities, which is a plus b to the power of 0 is 1. That can be simply written as 1. And then a plus b to the power of 1 can be written as a plus b, which means I can rewrite it as 1 times a power 1 into b power 0 plus 1 times a power 0 into b power 1. Next, a plus b the whole square can be written as a square plus 2ab plus b square, which can be redefined as 1 times a square into b power 0 plus 2 times a power 1 b power 1 plus 1 times a power 0 b square. Similarly, a plus b the whole cube can be written as a cube plus 3a square b plus 3ab square plus b cube. That can be rewritten as 1 times a cube into b power 0 plus 3 times a square b power 1 plus I will just correct this. Two places it is there. Yeah. Plus 3 times a power 1 b power 2 plus 1 times a power 0 b power 3. So like that, it can keep on going, and in general, we can write this as a plus b to the power of n is equal to summation NCR b power r a power n minus r. R is ranging from 0 to n. So, I mean, if we substitute n for 2 in this, we will get this expression. Similarly, if we substitute n for 3, we will get the fourth expression like that. So, what can we observe from these above expansions are the number of terms is 1 more than the index. Means index is nothing but the power. If the power is 0, number of terms is 1 more than that. If the power is 1, there are 2 terms. If the power is 2, there are 3 terms. If the power is 3, there are 4 terms. Like that, number of terms is 1 more than the index. Then, if you look into this, the power of A is getting decreased. Here it is 1, then becomes 0, whereas power of B getting increased. 0, 1. Here it is 2, 1, 0 for A. For B, it is 0, 1, 2. Here, for A, it is 3, 2, 1, 0. And for B, it is 0, 1, 2, 3. Like that. We may notice that there is a pattern in the coefficients of each term also. Like this, it forms a triangle type, which we call it as a Pascal's triangle. And you may notice here 1, 1, 1, 2, sorry, 1, 2, 1, 1, 3, 3, 1. That is what is filled up here. And you may notice this corner numbers are always 1 here also, and right corner also, left corner also, it is always 1. And first number we can write it as 1, then we can write it second terms as. This is basically coefficients of the binomial expansion. These are the coefficients, and these are the index. If the index is 0, then you have 1 term. If the index is 1, you have 2 terms. If the index is 2, it has got 3 terms, then 3, then 4, like that. We may notice a pattern. This 2 can be obtained by adding this 1 and 1, you get this 2. And if you look into this 3, 1 plus 2, you get this 3. 2 plus 1, you get this 3. 1 plus 3, you get this 4. 3 plus 3, you get this 6. 3 plus 1, you get this 4. What do you mean by this coefficients? When we actually expand a binomial expansion, the coefficients for an index of 4, you get this 1 is the first coefficient. Coefficient of the first term, coefficient of the second term, coefficient of the third term, coefficient of the fourth term, coefficient of the fifth term, like that. The above is called Pascal's triangle. Using this, it will be easier for us to expand any of the expansion of the type a plus b to the power of n, and which is called binomial expansion. Now, the r plus 1th term, whatever I wrote inside the summation, that is what is the r plus 1th term. The r plus 1th term of a binomial expansion is known as general term, denoted by t suffix r plus 1, given by t r plus 1 equal to ncr. a to the power of n minus r, b power r. Same thing only I wrote it here, right? Then the middle terms in the expansion of a plus b to the power of n will be as follows. If n is even, then the middle term is n plus 2 by 2th term. And if n is odd, then there are two middle terms. One is n plus 1 by 2th term. Another one is n plus 3 by 2th term. Now, let us do some questions in this. First question is expand 4a plus 2b to the power of 4. We may notice here the n is 4, means the power is 4, which means the Pascal's triangle, will be as follows. So we will have 1 and then we will write 1 here, 1 here. Then you will write in the corner 1. Here 1 plus 1 we can write 2, and then the corner we will write 1. Here 1 plus 2 we can write 3. 2 plus 1 we can write 3. Here in the corner you will write 1. Here also in the corner you will write 1. Here 1 plus 3 you can write 4. 3 plus 3 you can write 6. 3 plus 1 you can write 4. Then in the corner again you will write 1 here and 1 here. I wrote this many. Why? Because this will be your index 0. This is index 0. This will be for index 1, the coefficients. This will be for index 2, the coefficient. This will be for index 3. This will be for index 4. So we need for the index 4, what will be the coefficient? That is why I I made the Pascal triangle up to this. Now, here we may notice our, if I consider this as a plus b to the power of n, here a is nothing but 4a and b is nothing but 2b. Now, based on that, we will proceed now. The expansion, that is 4a, hence 4a plus 2b to the power of 4 will be, we may notice first coefficient is 1. So 1 times I will write a, that is 4a to the power of 4. And b will not, will have only 0, we can ignore it. Plus second coefficient is 4. And we will reduce the power of a now, means 4a now. 4a's power will become 3. And then 2b's power will become 1. And then next coefficient is 6. So 4a to the power of 2, because you keep on reducing the first term's power. So 4, 3, 2. And then second term's power will increase. In the sense, here it will be 2b to the power of 2. And then plus 4 times, because next coefficient is 4, 4 times 4a to the power of 1, we can ignore 1, and then 2b to the power of 3. And the last term has got a coefficient of 1, and we don't have 4a to the, because it will be 4a to the power of 0, which we can ignore it, and we will write only 2b to the power of 4. So therefore, your 4a plus 2b to the power of 4 will be 4 to the power of 4. 4 to the power of 4 is 256 times a power 4 plus, now let us calculate this 4 into 4 cube into 2. 4 into 4 cube into 2, we will get 512. 512 a cube into b plus, next is 6 into this 4 square is 16, this 2 square is 4. So 6 into 16 into 4, we get 384 times a square, b square. And then plus we have here 2 cube is 8. 8 into 4 into 4, we get 128 a b the cube plus 2 power 4 is 16, so it becomes 16 b to the power of 4. So that will be the expansion of 4a plus 2b, the whole thing to the power of 4. In this question, we need to find the coefficient of x to the power of 5 in x plus 3 to the power of 8. So we will first write the general term. General term is t r plus 1, which is nothing but NCR b to the power of r, a to the power of n minus of r. Now, here our n is 8, a is x, and b is 3. So therefore, this tr plus 1 will become 8cr 3 to the power of r, then x to the power of 8 minus r. Now, if you are interested in x power 5, then this x to the power of 8 minus r should be equated to 5. So, if 8 minus r is equal to 5, then r will be 3. Therefore, we can write this tr plus 1 as t3 plus 1, which is nothing but term 4, means r is 3. So you will have 8c3, 3 to the power of 3, x to the power of 8 minus 3, which is 5. So this is nothing but 8c3, we can expand it. 8 into 7 into 6 divided by 3 into 2, and then 3 cube is nothing but 27 to the power of, multiplied by x to the power of 5. Now this gets cancelled with this, and 8 into 7, 56, 56 into 27, we get 1512 times x power 5. Therefore, coefficient of x to the power of 5 is 1512. That is the solution for this. Find the coefficient of x power 6, y power 3 in x plus 2y to the power of 9. So here A is nothing but x, B is nothing but 2y, and n is 9. The general term, that is tr plus 1, is ncr b power r, a power n minus r. So we will substitute the relevant values: 9cr, 2y to the power of r, then x to the power of 9 minus r. So since we need x power 6, and if I put n minus r, if 9 minus r equal to 6, then our r will be 3. We can verify that here also y cube. So we get x power 6, y power 3. So we get now t3 plus 1 will be 9c3, 2y to the power of 3, then x to the power of 9 minus 3, which is 9 into 8 into 7 divided by 3 into 2 times 2 cube is 8, and then y cube, and then this is x power 6. So now this 3 goes with this 3 times, this goes with this 4 times. So we get 3 into 4 into 7 into 8. So we get 672 y cube x power 6. Therefore, coefficient of x power 6 y cube is equal to 672. That is the solution for this particular problem. Find the middle terms or terms in the expansion x plus 3 to the power of 8. So here our n is 8 and it is even, and hence the middle term will be middle term will be n plus 2 by 2th term. That is n plus 2. That is 8 plus 2, 10. 10 by 2 is 5th term. Now we have TR plus 1, which will be equated to T4 plus 1 because you need T5. That means our R value is 4. So this TR plus 1 can be written as NCR B power R A power N minus R. N value, we know it is 8, and C R value is 4, and then B is nothing but 3. So 3 power 4. A is nothing but X, and N is 8 minus 4. That means 8C4, we can rewrite it as 8 into 7 into 6 into 5 divided by 4 into 3 into 2 times 3 power 4, that is 9 square, which is nothing but 81, and this is X power 4. Now this 4 and 3 goes with this, and this goes with this 2 times. So we get 7 into 2 into 5 into 81. We get 5670 times X power 4, which is our middle term. Only one middle term if the n value is even. So that is the solution for this particular question. Find the middle term or middle terms in the expansion x plus 2y to the power of 9. So in a binomial expansion, if the n is odd, let me write here, n is equal to 9 and it is odd, then its middle terms, there will be 2 terms, or one is n plus 1 by 2th term, and other one is n plus 3 by 2th term. That is n is 9, 9 plus 1 by 2 is 5th term. So I will say that is 5th term, and 9 plus 3, 12, 12 by 2 is 6th term. So 5th term and 6th terms are the middle terms. So to find out the 5th term and 6th term, we will again apply TR plus 1 is NCR B power R A power N minus R. So here we will substitute first R as 4 to get T5, and that will be N is 9, C, R is 4, and then here R is 4 in this case, right? So 9C4, and then B is 2y to the power of 4, and then A, which is X, to the power of N minus R, that means 9 minus 4. So this becomes now 9C4 is nothing but 9 into 8 into 7 into 6 divided by 4 into 3 into 2 times 2 power 4, which is 16, then y power 4, then x power 5. So that is your middle term, first middle term. Let me simplify this. If I simplify, means if I multiply these things, 4 and 2 gets cancelled with this 8, and this goes with this 3 times. So 3 into 7 into 6 into 16 into y power 4 into x power 5. We get 2016, and then x power 5 y power 4. That is one term, one middle term. Then next, what is that? N plus, that is 6th term. If I want 6th term, this is our 5th term. Then 6th term is nothing but T6, and that can be written as T5 plus 1. So here R is 5. R is 5. that means this can be written as NCR, that is 9C5 B, that is 2y to the power of 5, and then x to the power of 9 minus 5. So 9C5 is the same as 9C4. So I will rewrite the same thing, 9 into 7 into 8 into 6 divided by 4 into 3 into 2 times, here 2 to the power of 5 is nothing but 32, and this is x power 4 and then y power 5. So again, this goes with this, and then this becomes 3. So now 3 into 7 into 6 into 32, we get 4032 x to the power of 4, y to the power of 5. Therefore, the middle terms are one is this 2016 x power 5, y power 4, and 4032 x power 4, y power 5. That is the solution for this particular problem.